Hi, 8th graders. Today we're taking a look at Lesson 5, which is First Consequences of FTS. That's what we've been looking at in the last week. So let's make sure we know what that means, because that would be kind of not good, I guess, right? If we didn't know. Fundamental theorem of similarity. And you're looking at page 49 of your book. Mine looks a little bit different. So I'm going to give you a second to turn to page 49, but then I'm going to show you how they came up with the lines that they've already added in yours. Okay, in mine, it tells me that the diagram below, P and Q, have been dilated from center O by a scale factor R. And then it says line segment PQ is parallel to P prime Q prime, which equaled 5. And, PQ equals 5, and P prime Q prime equaled 10. Okay, so the first thing that we would need to do is it says determine the scale factor. So on yours, determining the scale factor, how did we do this? Well, we know if we started with P prime Q prime, that would equal the scale factor times PQ. So we did last time, we divided by, PQ, and divided this side by PQ. So we can kind of skip ahead and just start with our PQ prime Q. So PQ prime Q is 10, and PQ was 5. 10 divided by 5 is 2. So we know that our scale factor is 2. Now, it says locate the center O of dilation. Well, if we need to, we're going to need to work backwards to get that. We know that these two lines are parallel, and we know that just because of this theorem. Okay? However, if we've already known that P was dilated to P prime, we can work backwards. So by working backwards, we're going to take from P prime, and we're going to go backwards through P. Because I know that by doing this scale, moving P to P prime, it has to be the dilation, the center of it has to be on this line somewhere. Then I'm going to take a second line and I'm going to go from Q prime through Q. And by doing that, I now can spot where the two intersect. And that point of intersection right here is going to be my center of dilation. So I'm going to label that as an O. Because center of dilation from center O. So locate center O, we did. Now it says measure the segments to verify that OP prime is right here. Let me get my, OP prime is right there. And OQ prime, and we want to show that OP scaled is OP and OQ scaled is OQ prime. Okay, so we need to show our work for that. As you measured your diagram, in yours it's already written. And it tells you that here is 3. OP prime, this whole distance, is 6 for the whole thing. And then over on OQ, this is just a 4, but the whole length is 8. So working with that knowledge, we can go down here and we can fill in our OP prime, which is 6, over our OP, which is 3. 6 over 3 is a scale factor of 2. And let's verify the second one. So we have our OQ prime, which is 8, our OQ, which is 4, improper again, scale is 2. Let's go ahead and look at exercise 2. It's on the next page, page 50. And it says in the diagram below, you are given center O. We see center O, and we see that ray OA. Point A is dilated by a scale factor of 4. Use what you know about our fundamental theorem of similarities to find point A prime. Okay, so we're hunting for A prime. Well, taking a look at this, we can see that we have a diagonal here, but we can really go like this and draw a parallel line. Okay, we could draw our parallel. And we know that this is 1, 2, 3. And we want it by a scale factor of 4. So if the original was 3 long, 3 times 4 should be 12. And we could draw then this line directly up there to the top. Oops, I'm a little off. And then we can mark A prime. Let's go ahead and go to the next one, page 51. On page 51, we notice we're given same thing, center O with a ray OA, and point A is dilated by a scale factor of 5/12. So what do we know about 5/12? What do we know about that scale factor? Is this getting larger or smaller? Good, it's definitely getting smaller, okay? So we need to work backwards. So as we work, we're going to go ahead and take that. And right now, our scale, let me draw it, our line is right here. And so we know that we have 12 going across. How are we going to get it 5/12? Well, here's my 12. Here would be my 5/12. Oh, I'm off on all of these. Maybe there. Sorry, guys. What's up? Let's see if I can just delete that and start again. Because we know it's at 5/12, and here is 5 out of the 12. So our ordered pair, or our point A prime, is right there. All right, let's look at the next one. Problem set 1, ready? Dilate point A, here it is, located at 3, 4, from center 0 by a scale factor. And here's our given scale factor. Now, we can look at it if we know our scale factor is 5/3, and we know that we've done this yesterday, we would take 3 times 5/3, and that's our x value, and our y value is 4 times 5/3. So as we do that, we can cross cancel here. My x value is simply 5. And if we multiply here, we can't cross cancel, but we can multiply across and get 20/3. And 20/3 reduces to 6 2/3. So my y value is 6
Not that I don't love giving the neighbor.
2/3. And there's my ordered pair. So I go over to 5, up to 6 2/3 of the way. I notice on mine that they have put mine at 3, 3 instead of 3, 4 because I was very concerned of why this didn't go through my line. Oops. That's not what I wanted. There we go. I know what I need to do. There we go. So there it goes through. And we see that A prime now is located right here. All right, looking at problem 2. Okay, problem 2. And it says, dilate point A, located at 9, 7. Here we are, 9, 7. From center 0 by a scale factor of 4/9. Then dilate point B, located at 9, 5 from the center by a scale of 4/9. And what are the coordinates now? So same thing, okay? So let's go ahead, and the ordered pair of the first one is 9, 7. So we know 4/9, it's getting smaller, so we know it's going to get closer to our 0. So we can take 9 times 4/9. And we can cross cancel, leaves us just a 4 as our x value. So our first x value is going to be a 4. And our second one, we're going to say 7 times 4/9. Can't cross cancel, so we multiply crossed. 7 times 4 is 28 over 9. And we can reduce that. 9 goes into 28 3 times. And 1/9 left. So our first ordered pair is 4, 3, and 1/9. So approximately there, and let's go ahead and draw that line. Okay, oops, I just moved that off. And then our second one, there we go, is, let's look at that ordered pair. It is 9, 5. And let's go ahead and fill in. So we have 9 over 1 times our 4/9. And the second one is 5 times our 4/9. 9's cancel, leaves us just a 4 for the x value. And then we have 20 over 9. 9 goes into 22 times, and this time 2 is left over. So our second ordered pair is 4 and 2 2/9. 4, 2 2/9. Go ahead and draw our line. And you notice that they are equivalent. Our scales worked. You can see our A and B were vertical on the same vertical line, and our A prime, B prime, again, is on the vertical line also. There's A prime, B prime. All right, go ahead and head back to the classroom.